Good day, everybody. If you can hear my voice, just put a confirmation in the box so we can start the class. Thank you very much, احسان. طاعت شما هم قبول باشه. Inshallah, your prayer will be accepted. That one, Qasim, about the exam, I will talk about it later, and I will explain what are the questions. Yes, and also similar to exam questions, Ali already told me what is your request. Similar to exam questions, I will assign and define some homeworks for you in the portal later, inshallah. Okay. So regarding the chapter 3, we will review what we already discussed before. Okay, we will review the whole chapter. It's a survey today, as you requested. Some of the students asked about salt, and some of the students asked about certificate, and they asked whether it's possible to explain them or no. So the first thing is we discussed before was passport. The basic idea was to use something that you know for authentication. Okay, for authentication, something that we use, it's better that I go to board so I can explain it and also add some Arabic to it for authentication, or in Arabic we say esalat. Okay, for authentication, or we call it esalat. There are different ways for authentication. The first thing is what you are. Okay, what you are, it's like fingerprint, like face, like voice, etc. Okay, the first thing is what you are. Yeah, salah. Okay, the next thing, or the another way to do authentication is what you have. Okay, everything that you hold or do you have. To have in Arabic is لديك. Okay, or لديك. Thank you, and also Ramadan Mubarak to you. Yes, exactly, like cards. Okay, and also like keys. And another way is when you use a smartphone, for example, plus SMS, or you use computer plus, or phone plus email. What you have, it's like a key, a card that you have. For example, you use card in ATM or other bank. Okay, that's something that you have. And the third way is what you know. Is ماذا تعرف. Okay, yes, exactly, like passport, ماذا تعرف. Okay, it can be like password, it's like pin, it's like patterns, okay, and so far and so on. So these are yeah, ماذا تعرف. Yeah, exactly. These are the three types of authentication that you can use for entering the system. And when we wanted to talk about the authentication, we said that discussing about authentication can be divided into two different subjects. We talked about authentication in two different areas or about two different subjects. The first one, exactly, thank you, Ali. The first one was in system, and the second one was for network. The first one is for system. This one is أول, and this one is ثاني. The second one was about the network. So login and transfer, exactly, Hussein. Yes, thank you. For the system, we said that the idea is to have a password. Saleh, thank you, Saleh, and you too. Okay, for the system, the idea was to have a password and store it in the system. So the problem was how to store the password, and then another problem was how to check the password. It becomes كيف تحسین and how to check كيف تفحص, okay, or تتأكد or something like that. Okay, so this is the whole thing that we want to discuss in this chapter, and we already discussed in the last two sessions. It was the whole thing. تفحص, yes, exactly. كيف تحسين and كيف تفحص. So for storing, first now we want to discuss now in this chapter we want to discuss salat, okay, and then we talk about what you know, or passwords, okay, what you know. And then the first thing we discuss is in systems, okay. And here in the system, the first thing that we discuss is that's how to store the password in the files, because the files is general and everybody can access it. So how we store it to make it confidential or مؤتمن, okay, how to make it مؤتمن. I'm using Khula, if I'm not mistaken. I'm using Google Translate, so it's not that I know all the words. I just use the Google Translate. Anyhow, so I review again. As I said, we want to talk about salat, okay, and we talk about ماذا تعرف, the password and PIN, what you know. And the first thing we want to talk about the systems and how you store the password in the system. When you have a password, for example, you have a password, for example, your password is, so this is for storing the password. Okay, when you have a password, for example, is 123, the system first asks what is your username. Okay, when you want to store the password, for example, you say, okay, I am Ali, and then the system asks what is your password, and you say, okay, my password is, for example, 123. What happens in the system is that it takes both of them and it creates a record for Ali. Okay, it creates a record for Ali with this, with these information. It says first Ali. Okay, first this is the user, and then it stores now the access. For example, full access or access, we say access type. Or I can now remove access type for now, later we will discuss it. Then for password, it takes the password, okay, and it also generates, the system generates a random for example 2-character word. So the system creates a random 2-character words. For example, in this example, the system creates M and X, for example, okay, capital M and X. Then it adds 1, 2, 3 to M and X. It adds these two and it calculates hash of 1, 2, 3 MX. Okay, and it comes something like this. Okay, then it copy this one and put it as a password. For example, Control C, and then it says MX. It stores after Ali MX, and then this one, this is the password, and at the end, for example, read and write something. This is the access. So when we store information like this, the system stores the password in the formula hash password plus salt. Exactly, yes, thank you. So when you store like this, this is username, and then this is salt, and this is password, and this is access rights. Yes, yes, Ali, MX is salt, exactly. So this is username. I will just point out each field. Okay, this is password, and this is the access right. It's like this. Username, salt, password, and access right. It's like this. Okay, so it stores these records for Ali, and now the process of storing the password finished. Now when you want to enter, when you want to enter, okay, عندما تريد الدخول. This is the next one. The first one was when you wanted to store the password. When you want to enter, the first thing system will ask is that what is your username. Okay, the first thing it will ask what is your username, and then for example you type I'm Ali. So it will go to the database, it takes Ali, okay, and it will go to database and will find the record with the username Ali. Okay, first it will find the username or a record for Ali. Rashad, salt, it depends on the systems, operating systems, and it differs. When the salt, I will write it, I will type it here. Okay, when the salt is bigger, okay, when the salt is bigger, security is stronger. So it depends on the operating system. Why does salt have 2 letters? It's possible to convert to more than? Yes, exactly. Same question Rasha asked Mustafa. Okay, so for example in Linux, okay, salt is 12 bits, exactly 12 bits. Okay, but maybe in Windows 10 salt is, I don't know, maybe 32 bytes. Okay, it's possible that maybe for example in the next version of Linux is for example 64 bytes. Okay, and that one it was 12 bits, okay, or something like that. So it depends on the operating system. In my example, okay, in my example, in my example it is 2 bytes. Or we say 2 characters. Okay, the salt is not a method for encryption, we just use it. It's random generated. Okay, so in my example it's 2. Now for checking more bytes, yes, exactly, Ibrahim, more bytes, more security. We talk about this one just a bit later. After that we discussed how we enter the system. So when you want to enter, okay, when you want to enter عندما تريد الدخول, okay, a system will ask what is your name, and you say Ali. Then the system asks you, it says, okay, if you are Ali, if you claim that you are Ali, what is the password for Ali? Okay, it will ask you what is the password for Ali. So you enter the if you are Ali, you enter the correct password. If you are not Ali, okay, you enter the wrong password, so everything will go wrong and you cannot enter. But if you are Ali, you enter 1 2 3. Something that happens, because this is the record for Ali, you look at here, this is the record for Ali. It will take the salt for Ali, which is not something hidden. Okay, the salt for Ali is not something hidden. So it will take the salt for Ali and it will add it to your claim. So it becomes something that you claim is 1 2 3. Okay, and something that is the salt at the moment for Ali is mx. Okay, it will calculate the hash for 1, 2, 3 and mx, and then whatever the result is, it will compare it with whatever stored here. Okay, it will compare it with this one. Okay, now we say if equal you log in, else it gives you error. Okay, this is the whole process. Okay, now I want to calculate the hash and give the reason why we used hash, but first I want to make sure that you understood how we use it. Is it okay? I went very slowly so everybody can understand. Okay, so if the password that the person entered is equal to the password in the system, you log in. If it's not, it gives you error and says, okay, for example, instead of 1, 2, 3, if you give, for example, 5, 6, 7, okay, 5, 6, 7 here, 5, 4, 5, 6, 4, 5, 6 plus mx will generate different result, and this result is not equal to what exists in here, and it does not let the person to enter. So now why we use salt? Let me see what Hussein said. No Hussein, even one person in different ways or in different times enters the same password, the salt will be different. It just generates randomly based on the transaction, not based on the person or based on the record. Okay, it will change, definitely it will change, and that's the thing which is valuable for us. Okay, now you see, now why we use salt. The reason that we use salt, it's here, I will put it here. You see, the reason that we use salt is that if the password for one person is 1, 2, 3, okay, the hash of the password, for example, tghj at this one, okay. For example, if somebody's password is 1, 2, 3, the result for hashing the password will be this one. So for example, if you have another person that the password is 1, 2, 3, it's obvious that the result is again this one. But you see, when you use salt, if someone's password is 1, 2, 3, it generates a random salt number. For example, for the first person, for Ali, it becomes 1, 2, 3 plus mx. So this is not similar to this one that you can see here. Okay, again, if Mariam, for example, assign its password to 1, 2, 3, it will be the salt for Mariam, maybe it's ke. Okay, it's another thing or different from Ali. So it's again different, it's not this one. So if again Ali changes his password, and again puts his password 1, 2, 3, it becomes this one, Ali plus T. Or I don't know, it again Ahmad changes his password to 1, 2, 3, it becomes this one. So if you look at the passwords for Ali in different times, okay, an encrypted password of the Ali, And if you look at the encrypted passwords of Maryam and Ahmad in the file, because you have access to this file, okay, and you can see this one. You cannot see 1 2 3, but you can see the hash of password. If you look at the file, you cannot guess, okay, so this is 1 2 3 and this is 1 2 3. It's different. And now we talk about dictionary attack and brute force attack. I will go to the next slide. When we say dictionary attack or brute force attack or exhaustive search, it means that we try everything possible. We try in Arabic you say كل شيء ممكن. Okay, this is the way of attacks. Just let me see, what did you set in the box? Is the salt constant for each intersection process, or does each intersection process? It always changes. As far as you change the password, Hossein, it changes. For the reason of salt, I will explain, Ali. Marva, we use salt because the attacker can predict the password using the hash. Yes, exactly. So you see, we are talking about the attacks. Okay, I will discuss it, Ali. Now we are talking about the attacks. We say we can have dictionary attack or brute force or exhaustive search, that it says we can try everything, or كل شيء ممكن. What we can do is that we say all of the words. Okay, we take كل كلمات ممكن. Okay, we take كل كلمات ممكن and we hash all of them. Okay, it can be almost. Okay, we take كل كلمات ممكن and we hash them. Maybe it takes a long time. For example, maybe it takes 2 days or 1 month, okay, or maybe 3 months. Okay, it's not important how long it takes, because it's a long process. Okay, and we hash them and we create a قاموس جديدة. Okay, we create a new dictionary. We call it hash dictionary. Okay, we take all of the possible words, and from that we create a new dictionary. Okay, we use salt, Ehsan, not to make the login password easy for the attackers to guess. We make it harder for the attacker to guess. Anyhow, we take قاموس جديدة, which is the hash dictionary. Okay, and then we compare this hash dictionary with the system password file. Systems password file. Okay, then we compare يقارن, and then you will get the passwords. Okay, you compare them and then you will get you can easily get the password. This is when you don't have salt. Okay, this is, so I will write it here. This is without salt. Okay, when you have salt, the first thing is that you find user record. Okay, in my example, in my مثال, this is Ali. Okay, you find user record, for example, you find Ali. Then you should get Ali's salt. Okay, then you get Ali's salt. Okay, which in my example was MX. Now you have to create only one dictionary and only for Ali. This is a specific we call it محدد. I think this is محدد قاموس لعلی. فقط. Okay, محدد قاموس لعلی فقط. How you create this one? You get كل کلمات ممکن كل کلمات ممکن plus mx. You get كل کلمات ممکن plus mx, and then you calculate the hash. Okay, now you see when you calculate the hash, maybe it takes 1 day with your system, maybe it takes 1 month, okay, maybe it takes 3 months on your system, okay, to have a dictionary. Now after that you will have one hash dictionary, same as above. Okay, you have one hash dictionary, but this is only for Ali and this record. We call it one time use only, or is استخدام لبرة واحدة فقط. Okay, Nazar, here the attacker must create a special dictionary for each user, which makes the work more difficult. Exactly, Muhammad Nazar. Yes, it's exactly the same thing. So you see, when you use when you only use the user's password, because it depends on the kalamat, you can have one dictionary to use for all of the operating systems and all of the records. But when you use salt, for each salt you should create one specific dictionary, and you cannot use dictionary for everybody. This is يستخدم لمرة واحدة فقط. Okay, استخدم or لمرة واحدة فقط. Just once we can use them. Ali says, but when the attacker find the hash, he will find the password plus. No, Ali, it's impossible. If it sees the hash is not inversible. I didn't get what is your question, Ali. It's impossible. Definitely, you see, Ali, definitely. When if you also, because here you see we say كل كلمات الممكن. Okay, I will use another board. If you take كل كلمات ممكن, okay, and then you have another one كل salt ممكن. Okay, if you add these two, you will have a very big file. Again كل كلمات ممكن 1. Okay, and then you can hash it. But it's far bigger. You can hash it and you can have hash for all words plus all possible salts. So it's possible that you also use hashes to hash all the possible words, but it's a bigger space and it's more difficult for the hackers. Okay, just you start. I hope you understood the problem this time. Yes, exactly. Yes, exactly, Rasha. It's like that. Yes, exactly. Okay. Security is computational. It is possible, but the search space is far bigger. Okay, the search space is far bigger because for any bits, any number of bits, okay, because for any number of bits, 2 to the power of those bits, the dictionary is getting bigger. Did you get that? It's far bigger space, but it's possible. Okay, so this was all about the salt. As you can see, for example, I will talk about it on the slides. Maybe you understand it better, Ali. Let me go back to the slides to see what we discussed. If attacker knows the password, everything is okay for him to log in, because if somebody knows the username, okay, if somebody knows the username and if somebody knows the password, it can log in. So that's different problem, Rasha. If the attacker know the password, it's that's not our problem. That's the policy of the system. Okay, so basic idea is to use the system to check the password, how to store the password, how does system check, and how it's easy to guess. And we keep the password. Ali, they are together, password and salt are together, okay, but you cannot separate them when they hashed, okay. When you calculate the hash, they are together and you cannot separate them from each other. You only have salt, which is part of the password, okay. So I will discuss this computational later. Just let me go, okay. So because it is difficult, it is hard to keep the password file secret, so we should have something about the password. We hash the password and store the hash of the password, so h of the password. We discussed this one. So when the system, because from the hash of the password you cannot get the password, but from the password you cannot get the hash of the password. So when somebody wants to enter, it's like that, when somebody wants to enter, it's like that you get the input and you get the salt from the record and you calculate the ciphertext or the password and compare it with the encrypted password. If it is same, it will allow the system to log in. If not, it doesn't allow the system to log in. But Ali, listen, something that you ask, it's here. You see, for example, if computationally the password are 1 million entry, it takes 4 hours to check every password on the same system. The system minimum, for example, 14 hours, okay. But if you add salt, which is random to the system, for example, you use upper and lowercase and digits and also specific characters, okay. With the same system it takes 1000 years. So it is 1000 years instead of 14 hours. It's like that. Okay, if you add random numbers and random salt to the password, it will slow, you see, it will slow the dictionary attack, and it takes a long time to calculate the hash. And also it's impossible that you use the same hash dictionary for all of the operating systems and for all of the versions and for all of the users. It makes it impossible, okay. So this was all about the system and checking with the system. The next one that you said that you had problem with was on the network, or it was about the network. So I will go to the slide. I think it was, my screen was 43. No, it was 42. So now we talked about authentication. We talked about authentication and we talked about authentication for the system. We already discussed this one. Now we want to talk about authentication on the network. So talk about authentication in the network. The first thing we say on the network is that on network it's impossible for the people to see each other. It is impossible for people to each other. Okay, let me see what Asir said. Asir, I didn't quietly get what you said, but it's okay. Yes, Ali, sometimes translate everything, and also I try my best to explain everything also in Arabic. Okay, so من المستحيل أن يرى الناس بعضهم لبعض. In network is impossible for people to see each other. But these are, Asir, these are easy. Even you look at the figure, you understand what I said. And also the Arabic is there in the box, okay? So impossible for them, for A and B to see each other. So when, for example, Alice tells Bob that I'm Alice, Trudy can also tell Bob that I'm Alice. For example, if somebody here say, okay, I'm Ibrahim, okay, I cannot see Ibrahim, so maybe I think that it's Ibrahim, but maybe it's, I don't know, Maryam or someone else that is on the network. So we say, what can we do? Because when Alice says I'm Alice, Trudy can also, or attacker can also says I'm Alice. Okay, the first thing we say that, okay, Alice can use IP addresses, but IP addresses can be forged. If, I will write in the box, if we have access to the gateway or network, if we have access to the gateway or network, IP addresses and also URLs can be forged or spoofed. Forged in Arabic, I think nastiyat or jal, okay? Nastiyat or nastiyat or jal, okay? On the network, IP address can also be spoofed or be forged. So again, Trudy can also says I'm Alice, and it can easily, yes, the IP address of Alice can be forged. The next thing we say, like in operating system, مثل system عامل, okay, like in operating system, we can use password for Alice, okay, or hash of the password is same. But now we say that, okay, because this Trudy will listen to the conversation, it can copy everything. It can, for example, if the password is 123, okay, and the hash of the password is this one, okay, even if the hash of the password is this one, I myself can easily copy it and paste it again and repeat it again. You see, I copied and pasted again. So the Trudy can record the password. We call this attack, replay attack, okay? It means that we record or sniff اول or first we record and sniff, okay, and second use it again. And this way it is not important whether it understands the password or not. It is not important. Okay, ليس مهما whether Okay, this is Arabic of what I said. It is not important. سواء كانت مشفرة أم. Okay, it's not important whether it's encrypted or not. Muhammad, if there are uppercase and lowercase letter symbols and number, it will be the shadow. I didn't understand, Muhammad. So Marve, all we need is to copy and paste it regardless of whether we know the content of the word or no. Exactly. Thank you, Marve. Yes. Yes. And I appreciate if Marve, if you can just rewrite it in Arabic. So to guess the password through the continuity of the numbers, uppercase and lowercase and symbols. Ehsan, we do not talk about guessing. We can just easily copy the password because we just listen to the network or we sniff the network. We can easily get the password. Very easy. Okay, so no guessing. It's just copying the password. It's exact the password. So it will copy the password of Alice and then again put it here. Everybody just Marve wrote everything that you need. Okay. And then again, encrypted password also doesn't work because it can copy again and reuse it again. So because we don't want to use it, or we don't want everybody to listen and reuse the password, we need a password which is يستخدم مرة واحدة فقط. We need a password which is one-time use only, and we call this one-time use only nonce. So here I will write in note, you learn about replay attack, okay, and you learn about what is nonce. Okay, so when somebody says I'm Alice, Bob creates something which can be pseudo-random number or which can be random number or anything that it can use. For example, it can be date, for example, plus time plus big random number, for example. Penetrate. Muhammad, in this case it's not important how complicated the password is. You can copy the password on the network, so it's not important whether it's easy to guess or it's difficult to guess. We just copy the password. Okay, so here it's not the case. Yes, exactly. For each login process or for each authentication, okay, for each authentication, or we don't call it login, we call it transaction. Okay, for each authentication, Bobs gives the Alice a password and asks her to encrypt the password and send it back. So when they want to do something like this, when they want to generate one password together or encrypt the password, they need to have a shared key. So they need to have a we call it مفتاح المشترك. Okay, به حاجت الى مفتاح المشترک. They need to have a shared key and also shared algorithm. They need to have the shared key and shared algorithm. So when they have the shared key, Alice says I'm Alice, Bob sends a nonce, and Alice will encrypt it with shared key and send it to Bob. But if you remember, we talked about shared key, and we said that shared key, just remember this one, okay? It's very important. Shared key or symmetric key, shared key or symmetric key is one-time use. It's suitable for shared key. Do you have my voice, everybody? Can you hear me? Okay, thank you, Nazar. So the problem is with Riyam himself. Okay, so the shared, or I will type it again, shared or symmetric key are suitable for shared or symmetric keys are suitable for one time use, one transaction, and one-to-one relation. So this is important. Shared and symmetric keys are suitable for one-time use, and then one transaction and one-to-one relation. This is suitable. Otherwise, it's not suitable for using the shared key. So no, it's only two users. Two person who want to talk or have transaction. If Bob is a stateless server, which it does not require him to remember the challenge it sends to Alice, this protocol secures against actually it's not Mustafa, it's not the meaning of this is not the meaning of stateless. Even if the server is stateless, it should wait until it receives the encrypted R from Alice. It should wait, so it cannot throw R away. Okay, so when we have many different entities on the internet, okay, as one of your friends asked, for example, we have A and B, for example, and C, and we have, for example, millions of people, they want to communicate with each other, they cannot share a same key, okay, shared key cannot be used, okay, so we use asymmetric keys for communication. So instead of a shared key, we use asymmetric key. When Alice says I'm Alice, this is another solution. When Alice says I'm Alice, Bob will send her one nonce, okay, one random number, and it says, okay, if you are Alice, just encrypt it. Alice will encrypt it with its own private key, and then Bob will apply Alice's public key on the encrypted received password. It If Bob reaches the R, we say that okay, this is Alice. If the Bob does not reach it, the R, we say okay, it's not Alice. But the problem is that how we know that this is really a public key. Okay, so this is that how we know that this is really Alice's public key. We will discuss it after this one. So because we already passed 1 hour and this is Ramadan and we have 2 classes, it's better that we have a break. Okay, we have a break. And after a short break, we talk about asymmetric keys. So here I will type in the notes. Now is my system's clock is Iran's time is 15.07. okay, you will have break 2. We can put it like 20 minutes is enough. Okay, you get rest, I get rest, then we will start the class again to 15 to 30, and then we start at 15:30 and it says we finished. Let me write before. Okay, so we start around 15.30 and we inshallah will finish before 5 because it's Ramadan. I try to make it shorter. Okay, so take care. I will close the class after this, not right now, but I will start a new class with the new record. All the best.